Today's topic is Introduction to DBMS. First of all, introduction of myself. Hello everyone, I am Mishika Modi, a computer science and information technology student here at Acropolis Institution of Technology and Research. Today I am excited to share with you my presentation on Introduction to DBMS. I hope you find the information useful and maybe even a bit thought-provoking. Let's start. First, introduction to DBMS. A DBMS, a database management system, is a software system that is designed to manage and organize data in a structured manner. It allows users to create, modify, and query a database, as well as to manage the security and access control for the database. DBMS provide an environment to store and retrieve the data in a convenient and efficient manner. The next slide. History of DBMS. Data is a collection of facts and figures. The data collection was increasing day by day, and they need to be stored in a device or a safer software. Charles Bassman was the first person to develop the Integrated Data Store (IDS), which was based on a network data model. It was during the year 1970 that the relation database model was developed by Edgar Codd. Many of the database models we use today are relational based. It was considered a standardized database model from them. Later during the same decades, 1980s, IBM developed the structured query language SQL, which is currently being used as an interface to study DBMS. In the next slide, the question is what is the DBMS, Database Management System? Purpose: a DBMS serves as an intermediate between the database and the user, allowing for efficient data management and access. Key function: DBMS functions include data storage, data manipulation, data security, and data integrity maintenance. This key function of DBMS is explained brief in the another slide. Benefits: DBMS offers benefits to the data independency, concurrency control, and backup and recovery capability. In the next slide, key component of DBMS. First, database. The organized collection of data stored in a structured format. We just saw the definition of introduction of DBMS in the first slide. That is designed to manage or organize data in a structured manner. Second, database engine. The core component that manages data storage, retrieval, and modification. Third, query language. The interface for user to interact with the database, typically SQL. User interface, the graphical or command line tool for user to access and the manage of DBMS. In the next slide, type of DBMS. Relational DBMS organize data into table with rows and columns using SQL as a query language. The user gives the SQL command to perform a specific task to create relational database. Second, no SQL DBMS. Provide flexible schema, less data models, to key value, document-oriented or graph database. Object-oriented DBMS manage data as an object with support for complex data types and inheritance. They offer features like encapsulation, inheritance, and polymorphism, providing a more natural way to model and manipulate data. In the next slide, DBMS function. There are many functions of DBMS, but this is more important than others. First, data definition. Define the structure and schema of the database, including tables, fields, and relationships. Data manipulation. Allow user to insert, update, delete, and query data within the database. Data control. Ensure data security, access control, and transaction management within the DBMS. Data dictionary. Maintain metadata about the database, include its structure, users, and access privilege. In the next slide, DBMS advantage. First, data integrity. DBMS ensure data consistency and accuracy through various mechanisms. It involves maintaining referential integrity, validity data, and providing backup and recovery mechanisms. Data security. DBMS provide access control, user authentication, and backup recovery capability. It offers robust security features such as access control, authentication, and encryption to protect sensitive data from authorized access. Data sharing. DBMS enable multiple users to access and manipulate data simultaneously. DBMS facilitate data sharing among multiple users and applications, allowing concurrent access to the same data without conflict. Data efficiency. DBMS optimize data storage and retrieve, improving overall system performance. It means efficient transaction management and concurrency control. In the next slide, DBMS challenges. Complexity. DBMS can be complex to design, manipulate, and maintain, especially for large-scale systems. Security risks. DBMS must be carefully secured to protect against data breaches and unauthorized access. Cost. DBMS often requires significant investment in hardware, software, and skilled personnel. Scalability. DBMS must be able to handle growing data volumes and user demand over time. In the next slide, DBMS example. Some example of popular database software or DBMS include MySQL, Oracle Database, and many more. First, MySQL. MySQL is an open source relational database management system, RDBMS, with a client-server model. MySQL is a simple syntax and it is a mild complexity. MySQL structure and style are very plain. Developer even consider MySQL a database with a human-like language. Second, Oracle. Oracle is a relational database management system created and run by Oracle Corporation. Currently, it supports multiple data models like document, relational, and key value within a single database. The system is built around a relational database framework in which data object may be directly accessed by user. Oracle's multi-model solution allow for accumulating and processing a vast amount of data. There are many database systems in the world, but these are some common use software. So thank you so much. I hope you understand the introduction of DBMS.